Welcome everyone, and thanks for joining us for the second ever ATG Universal User Group, Charity Hospital New Orleans Scan Project Highlight Part 2. As noted on the screen, this project was 1 million square feet and contained 9,753 scans. So in other words, a huge project. We would like to thank everyone who was able to join us today, including any Revit and BIM user groups. Our goal for these universal user groups is to bring all user groups together around a topic that is trending across many areas of the AEC space. We think it will benefit everyone to hear questions and discuss solutions with others in our profession. We also want to send a special thanks to BNIM in Kansas City and Williams Architects in New Orleans for inviting ATG to be a part of the charity project team. So before we jump in, let's do a quick introduction. My name is Matt Linn. I am a licensed architect who has been practicing architecture since graduation in 2001. This past year, I made a transition into the field of technical services to assist others in the field of architecture, specifically with the software side and its use in our profession. My involvement with this particular project was to join the modeling team of transcribing these point cloud scans into a Revit model deliverable. Next, we have James here.
Hi, I'm James Hughes. My title also should say AEC Industry Specialist. Also, I'm a registered architect here in Arkansas. Matt and I actually share quite a few attributes as far as people that work at HEG go. We have similar backgrounds. I've been involved in the scanning side of this and was on our first universal user group with Mandy and also with Jeff, and am also part of the team of 5 people that have been modeling away on this inside of Revit, and can't wait to show you guys what we got going on there. After me is Jeff.
Jeff is joining us via phone only. Jeff, if you can hear us, please unmute yourself.
I'm here. Yes, I'm Jeff Landers. I was the lead on the scanning team on this particular project. We spent 4.5 weeks in New Orleans crawling all over this building. I have a construction background, and now I'm also an AEC specialist, but primarily working with the scan team.
Okay, so as James noted, this is a follow-up to our first ever universal user group, which was devoted to the scanning process of this building. So This presentation today will focus more on the Revit modeling process. For those of you who may have missed the first session, we encourage you to go back and listen, as you may gain valuable insight to the scanning process.
Yeah, and you might just take your phone out for a second and just take a picture of those 2 links, just so you'll be able to type them in, or you can wait until you get the link for this video after we produce this. But that will let you watch the first part just before kind of proceeding through on the second part.
Yep. Okay, so that top link will actually bring you to all of our webinars, all ATG webinars, and the bottom link is the first session specifically. Okay, so one thing to keep in mind today, this is not a webinar. We do not expect or want to be an hour-long one-way conversation. We will be using Zoom's chat function to accept questions, so please type in your questions at any time. We have a few short demos prepared, and we will answer any questions related to that subject immediately following each demonstration. So go ahead and type those in, and we will get to them.
Absolutely.
Okay, so some topics we will be covering over the next hour include linking point clouds into Revit, confirming correct point cloud locations, both vertically and horizontally, ensuring point cloud is level, utilizing reference planes, and applying custom view properties for clear interpretation of point cloud. James, you want to talk a little bit about the project?
You know what? I'm going to yield my time to Mr. Jeff Landers, who can tell you about the building, the size, its future use. And then after he's told you a little bit about the building, I'll just kind of mention again laser scanning, because for some of the people joining us, it will be their first time being introduced to what laser scanning is.
Okay, yeah. The building located in downtown New Orleans is just shy of 1 million square feet. It is a 20-story building plus a basement. There are over 4,500 individual spaces that had to be scanned throughout the building. And as I mentioned before, we're there 4.5 weeks, collecting over 14,000 raw scans and incorporated them into over 9,500 scans in the final scan project. And that was put into a format of unified RCPs for all the different floors, which is what the team is using to do their design work.
And Jeff, how many terabytes was that before it was edited down?
7.3 terabytes.
Oh my gosh. Okay, so these are big.
Yeah, and in the end, the unified RCPs for design were condensed down to 276 gigs.
Okay. And how did you chop that up for our design team? I know the answer to this, but I'm just kind of asking.
Yeah, we just went floor by floor and divided it that way. And then once that was all put into one unified scan, they have the ability, in order to turn off, like if they're only working in a basement, turn everything else off, or on the exterior, they can turn it on and leave everything else off, so that it's, doesn't weigh down your Revit or any design software that you might be in.
Yep. Well, I just wanted to take over from Jeff here and just kind of mention real quickly about laser scanning. This is one of the largest projects that you're going to hear or see somebody introduce as far as describing the process for laser scanning, which we did in the last user group. But I want to emphasize that laser scanning is something that we're doing even on the smallest scale. In fact, in single rooms is where we began, in complicated mechanical rooms. So I would say anytime that you've got existing conditions, whether you're doing an addition or a remodel, certainly if it's historic in nature, you should definitely get pricing on a point cloud scan, because just in the past couple of years, that price has gone way down, as now the software is able to register the scans together for you. And so you're really kind of looking at paying for someone's time out on site. In this case, I think it was something like 5 people over 2.5 weeks, if I'm not mistaken. It was roundabout there. All right, we've got our first question in. What's the fastest way to get a price on the point cloud scan? Jeff, I'm going to let you handle that one.
The fastest way to get a price is to contact ATG, get the appropriate sales rep, and they will get with me. We need at least to know the general square footage. It's nice to know how many rooms are in the building, and it could be as easy as getting a fire plan that's maybe already posted in the building. Pictures of that helps, but getting information to this location so we can look at Google Earth or whatever, as much information as possible, and we can get a price usually turned around in a couple of days.
Yep. And last time that we had the user group, we emphasized how laser scanning is way, way, way beyond simply measuring, hand measuring. And in fact, you're going to see several elements that you would not be able to field measure yourself. For instance, a serpentine walkway that's ascending as it goes. You would be out there with stakes and strings and string levels and racking your brain to try to figure out how to measure that appropriately. So Matt, I think we're ready to go on to the next piece.
Okay, it looks like we had a follow-up to that original question. It says, do you laser measure plenum spaces as well?
We do. I can let Jeff kind of answer that one more. It does take more time if we've got a lay-in ceiling. We've got an approach for removing ceiling tile and trying to be efficient in that, but it will add an additional volume of time to the scan process. Jeff, how good of a job do we do with measuring or laser scanning the plenum space?
In the plenum space, what we generally have to do is we remove a couple of tiles and just scan in the room, and then in the ceiling in the ceiling space. It's going to depend on how crowded it is up there on the information that we're going to get. We could go up more than one time in an area if need to be to get around mechanical stuff. But if it's wide open and you're trying to get structural it's pretty simple, but it does double the work in the scanning process.
Okay. So you can locate in that plenum space the structure. And in fact, if you're able to shine onto the structure, you should be able to get the exact profile and depth and flange thickness and all of that of the structure kind of as a bonus. Matt, we're ready to roll on to the next.
Okay. So from here, we're just going to go ahead and dive in to discuss methods in which we modeled elements. We'll be starting with the exterior of the building. So we thought the best way to kick this off is by looking at a series of images that were provided to our client on a weekly basis. So when viewed in sequence, you can see the progression of the model over the past 9 weeks. Okay, so this is week 1. We're not going to talk about everyone. We'll move kind of fast. And James, I'll let you kind of, if you want to add any comments, this is...
Yeah, you can see we started with the strips of wall in between and left the windows alone. We did have flooring put in. Then at this point, we had actually created stacked walls, which we later revised and changed that approach. But each one of these vertical 12-story ribbons of windows is a stacked wall sequence that goes from thin to thick, whether it has a window or not. Interior was added and a lot of extra detail around the edges. And some site detail starts to come in. Actually, that seems to be all the site detail on there now. Oh, there's all the site detail. Marvelous. Yeah. Backside, same story.
Yep.
So this is on the south face of the building.
I really like this view.
Yeah, you just fly your crop duster in there on the into the side into the doctor's waiting lounge. And then it got a lot more elaborate in week 2. That's where we spent most of our time there. Yeah, we took our time getting one curtain wall correct, and that's why you kind of saw one of them for a week. Look at that. Beautiful. Sorry, I did most of the exterior work. Just pat myself. Yeah, and you can see the windows kind of even shifting a little bit as we sort of grappled with whether or not to model the windows in their actual vertical position, which the building has differentially settled. And then we've later did revise that so that our windows have an even sill depth.
So here you can start to see a lot of the site elements being incorporated as well, all the mechanical units as well.
Yep.
Okay, back to you, James.
Sure, yeah. So we're going to demonstrate next just kind of the beginning process. You know, after in last, 2 months ago, last time that we talked about the point cloud, we talked about how you can link it in, but we didn't actually show that. And now we're going to demonstrate how to link in the point cloud so that this is not a 20-minute process to show you guys these things. I've got some kind of sped up video where I don't make mistakes, which makes me look great. Fast and great, but we're going to show you how to link it in, how to adjust the location of the point cloud within Revit, and adjust the elevation after that. Then we're going to apply some reference planes and begin to model the exterior walls. I'm not going to show you all of the exterior walls, just going to start that process off and show you how the snaps work. And so I'll do a little bit of play-by-play. To insert it, you just click Insert Point Cloud, select the point cloud, choose how you want to position it. It really kind of doesn't matter at that point, and boom, it pops in. Even though that was a little bit sped up, you should have it linked in just a few seconds. If you look at it in 3D, I do have a crop region here, but you can see that all the data in 3 dimensions has been imported into the Revit space. And so from here, I like to put in reference planes just so that I can begin to, push those to where the origin point is. And we're going to use that to manually align this thing. Now, there's lots of ways of aligning. I'm just kind of goofing around just to show you that you can do it quickly and pretty accurately here. But just move this corner to that reference point, and then rotate this thing just using RO or the rotate command. Maybe a little bit precise here and catch the exact edge there and rotate it perfectly plan view north. And we can cut a section here and take a look at the section and start to see the front of the building. It's sitting too high. And so we can just grab this point cloud and drag that piece down to level 1. And we've roughly located this project X and Y. I pinned it. That's best practice to make sure you don't end up moving it around. And I've sped this part up, but start striping in some new levels. You can nudge them up or down. You can type in the exact amount. This is a terrible view to put levels in. That's not how we actually did this project. I'm just kind of recreating this fast and loose here. We actually cut a section through the stairs and very precisely placed them. Here, I realize I need to drag these over so that I'm actually on the correct level of the building, but paying attention to the 3D extents of the levels so that they pass all the way through the building, and just stripe these guys all the way up. And then after we get up 12 or 13 floors, 14 and 15 sort of truncate in, and then 16 through 19 are above this, and they're not as big of a project. And then we got a 20th floor up there with some mechanical equipment on it. The numbering's wrong on that, by the way. Aren't you guys glad I sped that up? So we'll put in another point cloud too. This one's on the interior of the 3rd floor. And if you see it in 3D space, it's elevated wrong and it's rotated wrong. So I can just zoom in, grab the floor of that, drag it roughly down to level 3. I can see it spun out. And so I can move from one precise corner to roughly where that corner occurs, and then apply a rotation really roughly. That is not how we laid out Charity. I just played that one fast and loose. But you get it oriented. And then we begin setting reference planes. This was the approach that we took to make sure that these reference planes span all 20 floors. And so that's going to be very vital for making sure that your other vertical elements are in alignment. And right now we're just doing outside edge of the walls. You should pin these after you place them and are comfortable with their placement. If you know the thickness of the wall, then you can go ahead and offset that amount. And so here we were offsetting 2'3". I think I'm paused right now.
Oh, sorry about that.
It's okay. Just let me catch up to myself here.
Yeah.
You wouldn't believe how fast I'm a Revit demon here. This is 2x speed, by the way. I'm not this fast. All right, so I stretch them so that they definitely intersect past one another. I like to name them sometimes. And then I set a 4-inch inset because we've got limestone that actually steps in at the windows that you'll see here in just a minute a little bit more clearly, not so much on the 3rd floor. But to check or fine tune my rotation, I can see that that outer needs to rotate about 4 inches over a distance of about 400 feet. And so we'll go to the rotate command. I get a hard snap here exactly at the corner. I can zoom in and find, I mean, within 1/8 of an inch where that edge is, and then rotate it along the whole length of the building is now correctly aligned instead of fast and loose aligned with Project North. And this is key right here. I just limited the depth of the point cloud scan. So you're not seeing the points on the floor anymore. You see a 6-inch ribbon. If I change this to 310, now you get a little 2-inch ribbon of point cloud dots, and that lets you very precisely place reference planes and then later walls and windows and other elements. And so the key to working with point cloud scans is to limit the depth of your view, whether that's a plan view like this or a section view. And then we just kind of are quickly able to run through and set up some reference planes. This one's slightly off axis. And if you ever get this warning, elements are slightly off axis, I would encourage you to actually make it orthogonal, because it can actually cause hosting problems if you place a wall slightly off axis. Don't worry, we're not going to work our way around the whole building. I just wanted to introduce this concept of how we used reference planes so that we could, from the 4th floor, see what's happening down on the 1st floor and where the extents and boundaries of elements are. And this later helped us to realize what was happening with lateral movement on the windows. As you ascend upwards, the windows were sort of progressing to the north because the building was sinking down to the north, which the reference planes are perfectly plumb. And so it helped us to be able to measure that and kind of come to terms with that. So we can move this corner and kind of more exactly place this 4th floor scan here. And now you can see that kind of in and out undulation that that limestone has at each window piece. And that rotation is only about 1 inch over about 400 feet. So very precise kind of a check there to make sure that we get this thing where we want it before we start modeling elements. At this point, we're just taking some careful measurements and finding it was 4 feet typical there. Here we've got an 8-inch limestone offset. And so, or I'm sorry, 1 foot back here. You can modify that and use nice round numbers to a measured element. You don't have to do it that way. If you want to have fractional nonsense numbers, you can do that too. And then we can start to make choices about what the wall is going to be. And you do not have to guess correctly. You should justify it and set its height before you begin. Here I goofed up, but you can, because the level numbers are wrong, but we'll go from level 1 to pretty high. Start it exactly in the corner. You get a nice hard snap. And we're going to pass this main wall way, way north. It's invisible. I need to turn that on. There we go. And up it to fine level detail. Hit the space bar to flip it. And interior walls going easier. That measures 8 inches. So we'll just select a generic 8-inch wall for now. Later on, the customer is going to change those out to known construction. And you can just right click, create similar. Notice that you're getting snaps along point clouds. That's pretty new. I think in the past 2 years, Revit has started to create alignments along the axes of point clouds. It recognizes that cluster of dots as a surface or a potential surface and acts as an axis for you to align to automatically, which makes this, even if you slowed this to half speed of what it is now, it's still a pretty quick process to lay this thing out. All right. And Matt, if you could take a look over in chat and see if there's anything you want to chime in on. So that's just kind of a taste of how we laid out the interior walls, is kind of repeating that process and changing the wall thicknesses out to be the correct thickness, and so on and so forth, and added a lot of equipment and such later too.
Okay. Thanks, James. So we did have a question pop in. Did you use any other resources like the original plans to verify things like column grids?
Yeah. So we actually had several sources of truth, if you want to call them that. So one source of truth is we eventually found the original plans, but actually had finished about 70% of our work before we had that as a source of truth. I utilized doing the exterior. Google Street View was very handy for kind of those low lit areas. It was able to catch detail that I might otherwise miss. So it was just kind of a check for me. On the interior, we took a look at the original plans for structure, but we also had the point cloud was catching where the structure was, and we set up some view ranges so that we were looking at, where columns were and looking at where roof joists were. That wasn't my particular area, but we did have a couple of different sources for that.
Okay, looks like all the questions. We'll go ahead and move on now. Okay, so now we're going to shift gears and we'll start to take a look at the interior of the building.
That is really cool, having it peeled off like that.
Yeah, so this is, as James mentioned, this is the same view we had for the exterior. We just ripped off the exterior model and this is what you get. So just as we did with the exterior, we'll go ahead and view the weekly images that were provided to the client to show the progress for that specific week. Okay, so if you tuned into our first presentation, you know that we started the scans with a group. We scanned that stair 6, which is what you see down the middle there. And we used that same approach as we began to model in Revit. So we started with that and it became basically the backbone of both scanning and modeling moving forward. So this is week 1, week 2. And you can see we've added a lot of information. Again, this is 1 million square feet. So there's a lot of work in here. Okay. That was the northeast. So now we're taking a look at the southwest here.
And every one of these elements has been precision placed, which is just phenomenal. If you're just making stuff up and modeling it quickly, that would be one thing.
Yep. Okay, so now we're going to jump into our first interior demonstration. So this will illustrate the importance of visibility controls when using point clouds in Revit. So James already hit on a lot of these, but we're going to bring them home again because there's a lot more methods to control, and they're extremely important when it comes to modeling. Okay, so here we have the exterior model. the first thing we're going to do is go ahead and create a plan view. They don't show up, so we're going to not duplicate existing, and we'll select level 5. So as this pulls up, you can see here it is in the project browser, level 5. It's a little sluggish because it is dealing with a lot of data here, because we have all the point clouds, which is one on every level, and then we have all of the modeled elements on, and we actually have a link in here, and that link also has all of the point clouds. So we have a lot of data moving around here. So you can see it is a little bit sluggish.
As we mentioned a couple of weeks ago during the last one, this was, I think, around 634 billion points, but you've duplicated that because you've got it linked in as well.
Right. So you can see here in black, these are the walls. These are the casework we've put in. So the first thing I'm going to do, I'm going to come down and make this a fine detail level. As soon as I do that, you can start to see the pattern in the floor. You can see those little circles. So those circles represent everywhere Jeff and his team went out and set the scanner and basically did a 360 scan of the space. So every circle you see is where those are laid. So if you zoom in, you can start to see the plumbing fixtures, you get the labs, you get the toilets here. So I'm going to turn those categories back on. So now let's address the size and the lag of this, because we have so much data being transferred here. So I'm going to go first to visibility graphics, and I'm just going to turn off the model categories, and I'm going to turn off the annotation categories as well. So we're left with point clouds only. Okay, again, this is an RGB mode, so everything is the actual color. And we still have all of the point clouds. So I'm going to come in and I'm going to isolate just this 5th floor only by hiding all of the other point clouds. Actually, I'm going to turn on exterior and the stair as well. Okay, so now you'll see the regeneration time much faster. I can move it around. So yeah, that's a key when you're working with point clouds. You don't want to have more than you need on, because it's just too much information. So right here, you can start to see where the shafts are. A scanner will not scan through walls. So if you see a lack of a scan, it's more than likely a shaft. Okay, that's what we have here, the elevators actually. Right here, you can see that same type of situation, but that's obviously not a shaft. So if we figure out what's going on, I'm going to go to my view range here and pause here for a moment. View range is absolutely your friend, and James already pointed this out. But when you're dealing with point clouds, you have to use view range constantly.
Oh yeah.
And a good thing to do, we had 5 people in and out of this project, and really good practice is everyone has their own set of views. Because if I'm constantly moving my view range up and down, and James is in that same view with me, he might call me and say, hey, knock it off. You know, so it's good practice to go ahead and have everyone have their own views. So what I'm going to do, this is at its default, I'm going to bring it down 6 inches, and you'll see what happens. Okay, so when I do that, we can now see the floor. So what had happened is, in reality, that floor is actually a little bit lower at that location. So at the stairs where we determine the levels, and that was actually a little bit lower, thus it was below the cut plane. Okay, similarly, if I bring it up to 3'6", that's the bottom again, and I'm cutting at 4. So similar to what James showed earlier, this is a slice through the plan, and it really starts to look like a floor plan. It starts to look like a drawing. Now again, this is an RGB mode, thus everything is the actual color. You can see casework here because that is between that 3'6" and 4 feet. Again, it starts to look exactly like a floor plan. All right, for now, I'm going to go ahead and bring that view range back down to the -6 where we started. And I'm going to show you some other options you have that really help. And that's over here in the point cloud tab. You have options here with the color mode. Again, we started with RGB, and there's several options. First, we're going to look at single color. Now, when you first look at this, you're thinking, well, that's not too helpful, Matt. That doesn't help me at all.
That's awful looking.
It's awful looking, yes. But it does have value, and I'll show you one way in which you could use single color. So I'm going to flip on my 4th floor below, and I'm going to make it a single color as well, except I'm going to make it blue. And now when you zoom in, actually I need to go and change my view range. I need to make it so it's going down to the level below. Now, when you zoom in, you can start to see the alignment. You can see the stairs are, accurately aligned. The corridors are. And it's a good way to basically stack your scans and just kind of do a cross check between the floors and make sure they're accurately aligned. And if they're not, here's a good place to move them. So that's where I found really great value in the single color mode. All right, so let's go back to visibility graphics again. And I'm going to turn this fourth floor, I'm going to turn it back to RGB and just turn it off for now. All right, so I'm going to go back in. Some other color modes, we have elevation, and you can see it says max elevation and min elevation, and you get to select a color for each of those. And so what that does, again, not extremely useful in the plan view because it looks, again, not that great, right? But this has a use, and I'll show you here in a second. It's really more useful in exterior views, elevations, or axons, either way. Okay, I'm going to turn these off real quick. So,
by the way, what Matt is teaching you guys is not in any curriculum, by the way. This is stuff that you find out the hard way.
Yeah, on the job. Okay, let's look at intensity. Again, this also has max intensity and min intensity there in the settings. So max intensity white, min black. And so it just allows you to see the volume of points or scan data as you zoom in, you can see in and you can actually see the density. Where it is around the lav, they group together and they're more of a black, whereas the thinner ones tend to turn more gray. Okay, again, not extremely useful in the plan, but we're gonna go, here's my favorite, normals. So this is my favorite plan view use, because when you zoom in, you can see all of the east-west oriented vertical elements turn green, and all of the north-south oriented vertical elements turn red, and every horizontal plane, or the floor, is blue. Okay, so now elements really start to pop, and you can see the plumbing fixtures right there. And I'm going to go ahead and turn the model elements back on at this point. Okay, so right now we have all of our walls with no override. That's why they're, the black line has a white infill. And for me, this wasn't extremely workable because those walls are basically covering up your scan. So you can't see it. I mean, once you get them on, that's probably fine. But what I found really useful was to go ahead and come in here and give these walls a solid pattern of yellow, any color you want. Yellow seemed to pop really nicely. And then I would give it a transparency so we can see through the wall so you can easily find doors and so forth. Okay, so we'll start here at 25% transparency and zoom in. Okay, now that the walls are in, you don't notice a big difference. The difference is when you're laying them down. So let's grab this door and let's just delete it for now. So if you zoom in, you can start to see where that door should go. And actually, I'm going to undo that, and I'm going to change that transparency again to something even a little less. We'll go with 50 here. Okay, so now if we come in and delete this door, you can really see where they are. And it's, extremely valuable as you're drafting, looking for the doors or looking for the fixtures or whatever it is you're trying to get into your plan.
And if you zoom out, you know at a glance which ones you have done and where the work is.
Right. All right, so over here, you can see, again, this area is completely white. And that's because I turned the model elements on, including floors. And now that floor is actually covering up that point cloud. So if you do have conditions like this, obviously not every building is going to have this condition, but if you have some sloping floors and if they're above your point cloud, you can come in and give a transparency to your floor as well. And then when you execute that, you'll be able to see that point cloud through your transparent floor. And it's nice because you can still kind of see where that outline is and where it goes down.
You can see why Matt said make your own copies or duplicates of views so that mine doesn't end up 80s pastel.
James is not like the 80s, I guess. Okay, so let's jump to the exterior now, okay? A lot of the same principles apply. So first thing I'm gonna do, the model category is already hidden, annotation already hidden. So I'm gonna come over here to my point clouds, and I'm gonna go ahead and isolate that exterior one by hiding all of them and then turning exterior back on. Okay, so this lightens the load on the regen time. Again, this is the RGB color mode. So all the points you see here are actual color as gathered by the scanner. If you come over here to the point cloud, let's look at some of these same options we did in plan. Single color, red. Okay, not super helpful, but the option's there if you ever need it. Let's look at elevation. Again, you have a min and a max color, which you can make anything you want. And here, now you can start to see, looks like I forgot to apply it there. Let me go back into visibility graphics, hit that one more time. Elevation, okay. And then apply that. And now you can start to see all the blue stuff is down low, and as it transcends up, everything turns red, and there's a gradient in between. So, perhaps this is useful to you. And you could use it in elevation too to see the depth of that face. Okay, we have intensity. Say okay. As I would assume, you can see there's a lot of black down low because that's where the scanner was. There's a tree. If we zoom in here, you can really start to see the detail on this decal right here. Again, this is just a point cloud. That's not photos. It's pretty incredible.
Yeah, that's a punched metal art piece.
Yeah. Okay, and finally, normals. I don't use this terribly often in 3D, but it's the same concept. You have vertical walls, both in green and red, and then horizontal planes in blue.
That would have helped me catch that little shelf that you were just looking at, because I actually didn't catch that till the second week.
All right, so I'm gonna come back in. I'm gonna put this back to RGB. And I'm going to go ahead and turn them all back on and turn exterior off. So I'm sort of flip-flopping the order here. Okay, again, all of them are RGB. So here's something that could be useful for the single color. So I'm going to take the 5th floor and make it red. Same thing, I'm going to make the 4th floor and turn it blue. So this will enable us to easily locate those floors.
Yeah.
This could be useful to you. So you can see exactly where those floors land. And you'll notice not only is that floor blue, but it's also kind of going up the side of the face on the exterior side. So what that is when Jeff and his team were scanning, the scan actually goes out the window and it's catching points on the other side of the building. And actually it looks like the other side of the street as well.
Yeah.
Okay, so a lot of controls over here in Point Cloud, and I would recommend using all of them. Again, it's all preference, but my personal preference is definitely the normals for floor plan, and then kind of some overrides with your modeled elements. And again, I can't stress enough, constantly change your view range because that is your best friend when dealing with point clouds. Okay, did we get any questions that popped in during that? Let's see.
We did. So you showed off one of those was density. When is the best time to use density, or when do you use it to help? Where does it help the most?
Yeah, good question. And honestly, I don't use it. So I'm sure there's a good reason out there. I don't know, James, have you ever used that one?
It helps if you need to see. It's not an X-ray view, but if it looks really flat, what you're looking at looks flat. Changing it over to that can help you actually detect when there is a verticality to the surface, or when there's lots of points on top of themselves. Normally, in a plan view, that means you're looking at something vertical. Is how it helps. So if you're looking for columns or something like that, you could turn that on, and if they look like a square, just like everything else that's flat on the floor, it will then pop out a little bit more.
Okay. There you go. Okay, so we're going to go ahead and jump to the next. Any more questions? Looks like that's it for now. Okay, so this next demo, we will highlight an auditorium that exists in the basement. There are also a couple on the 12th floor, but this specific one is in the basement. We had a little teaser with this during the first presentation that James did a couple months ago. If you were in that, you saw a little taste of that. So this is kind of the end result. Okay, so again, we are here in the basement, and I have my normal settings for plan, which is, as you know, is my favorite. So you can see the blue tells me exactly where, first I'm just going to turn off my modeled elements. So we're just looking at the point cloud now. But what I like about this normals is you can see the floor, and up in that upper right-hand corner, there is no floor. Either it's below my view range or it's above or something, and you can start to see the stairs as well. So you got stairs coming up this way. Looks like there's something going on here and even something in here. Okay, so that's what we can extract to begin with from the plan. So again, our best friend view range when dealing with point clouds, I'm going to bring the bottom down to 10 feet below. Okay, and then those floors pop up. So right there, that can tell us, well, we know there's a floor and it's down, and you can see the stairs, and we know that stair goes down. The other ones didn't pop up, so we could probably safe assume the other stairs go up. But there is another floor down there, which you can see. Okay, next thing I'm going to do, I'm going to raise the top up. Let's try 15 feet. Okay, it looks like we're above a ceiling. So let's bring that down a notch. Okay, now we can start to see what's going on. Okay, these stairs are coming up here. There's a level right there. Looks like there's some stairs down to that lower level, and then back up there again. Okay. All right, so I'm going to jump to this section. If you jump here, you can start to see the point cloud, and we're in RGB mode, so it's exactly as it looks. Okay, I'm going to hide the model category again, so we're only looking at point cloud information. And you can start to see that space. It's like little walls. Looks like it has a tile on it. It's got a little ladder up to the first level, and then stairs going up from there, little partial height walls. Again, this is an auditorium where they taught classes a long time ago, I believe.
Mid-1930s.
There you go. So I'm going to show you something James showed you earlier, and I'm going to toggle this clip section. It's at 50, and I'm going to change it to 10. So now it's starting to look more like a section. Okay, and you can go even thinner. So if we went with 1 inch, you can really depict that profile. Okay, that's a little thin. I'm going to bump it up a little to 6 inches.
I have never changed that parameter before. I've always visually changed it from the plan view. That's good to know.
Yeah, there you go. Okay, so from here, I'm going to go ahead and, let's see, turn my model work back on. And you can see we were able to accurately put exactly where those walls land according to that building section point cloud. So here's a 3D. Now imagine trying to do all this work, as James said, with a piece of paper and a tape measure.
No, sir.
Yeah. There are a lot of levels going on. That's the down right there, coming down to this lower level. Okay, that's what they taught. They have a table and a light down there. Here's the stairs coming up to the upper level. Okay, and then you got these intermediate ones that connect the upper and lower.
Sorry, this is the first time I've seen this space. They did a good job.
This was a fun one to build for sure.
Yeah.
Okay, so just kind of zoom around. There's some seats up here. Again, this is all extracted from the point cloud. Yeah, as James noted, we did not have drawings until just recently. So pretty much everything you've seen has come from the scans.
Yeah.
Okay. Okay. No more questions that I see. Any questions from this last demonstration?
There are fewer questions I'm noticing with this crew than the last one. They had all kinds of questions about which scanners we used and all that last time.
Okay. So great. We'll just move forward. Let's see what time. Okay, it's 3:45.
Yep.
I'm going to go ahead and jump over this one so we can. What do you think, James? Should we jump straight to the video?
Yeah, if we get if someone asks about different parts of it, like a multi-slope floor or something like that, we can jump in and show them live inside of Revit.
Okay. So at this point, we're going to go ahead and jump to an Inkscape. Inkscape, for those of you who don't know, is a real-time renderer which immediately updates all geometry changes, textures from your Revit model. So James has created a phenomenal animation highlighting his exterior model. So without further ado.
Yeah, if you don't, well, we'll just go ahead and show some of this. Some of this is just, yeah, just back it up real quick. I was going to ask Jeff, we did have a question come in. Jeff, are you still on the line? If you are, it is still muted.
Okay, Chris, if you could go ahead and contact our sales team, we will get you that information. And if you have a particular job that you're interested in, which is probably the case, we can get that, we can work out a scope with you as well.
Yeah, I was going to see if Jeff had an answer to that. I don't know if we're under NDA on that or not, but we can coordinate that answer with you if we have an answer to give you, Christopher.
Yep.
All right, next up, we got a little bit of a sizzle reel here inside of Inkscape, just some pride shots from the outside of the model. And just to kind of show some of the detail work that was put in. This is the exact railing. Every one of those posts is correctly spaced. This ADA ramp has an offset to it with gusset plates and offset vertical pipes. It transitions smoothly to a wall mount there. So all of this work, this piece was done probably in about 3 hours. Our front entry is solid limestone. Most of the railing has been removed, and then there is curved curtain wall up here. It's actually faceted, so it's 6-panel. And then this is the ADA ramp on the other side. Again, it's offset with gusset plates. And then the extensions, the posts, the height, the slope of everything is accurate to what's there.
I intentionally paused it so you can kind of describe here what you did with these railings.
Yeah. So basically they were modeled in place, which is kind of a, yeah. And that's actually coincides with the question in the chat. I receive each of those question marks as a holy cow. So that's how I'm taking it. These were modeled in place, which is a big no-no in most firms. If you create model in place elements inside of laser scanning, that is best practice to model in place. However, you don't want to have a library of model in place elements that can accidentally be grabbed. Model in place elements can have kind of wonky things that happen where elements inside of it can shift around or disappear. And so basically these were modeled in place first. And then after that was done, we did and you guys need to Google this if we don't have time to show it, but you can actually grab the model in place element. And so it's made up in this case of, I don't know, 60 extrusions and some sweeps and such. You grab all of it with a window, you group it inside of that group, and then you can do File, Save As, Library, and save the group out through that library. It's a little hoop because otherwise you've got no way to push out model in place elements as an RFA file. This is the only way to do it, and it's awesome. And so that gets pushed out as ADA ramp left side .rfa. And then from there, if we wanted to, we can make it fully parametric. Now we've left it monolithic because this is existing conditions. I don't need to make it to where we can stretch posts around. They are exactly where they go. But then I just save that RFA file and I load it into the project as a component and then just place it. And it is exactly the height that it needs to be. And then I erase the model in place component and put in the RFA family that's there. And it's a really solid result.
Yeah, as James noted earlier, that's not something you're going to get from a textbook either. And that is extremely valuable, especially for instance, like this, you have a post that is in fact replicated.
Yeah.
If you're modeling in place and then, copy pasting either the family or the extrusion, you're just increasing file size.
Yeah,
So,
you could burn 2 hours trying to make your own railing family and make it where it repeats every 4 feet, and then you realize, oh wait, I don't have a way to make this offset the way I want with a post. Maybe I could treat it as a support, and then burn another hour and try to do that. So, creating as model in place is definitely the way to go. Yep. So model it in place. Then you group the elements, the extrusions, all of that from within it. And then you're going to, after you've grouped that, you do file, save as, library, and then your mind is blown. That's the correct response. This really sharpens your game whenever you're working inside of a point cloud to be able to make proper Revit families. And in fact, if we do a post-mortem on this, if we were to continue to do work inside of Charity, we could push any elements into an RFA family, curate that, and make our firm library that much stronger with different individual pieces that we wanted to reuse.
yeah.
Go ahead and take us up the ADA ramp here, Matt.
Okay.
I hurried and made this Inkscape thing in about 30 minutes, so I didn't choose the sizzliest places to look at. I just wanted to point at some of the details. This is just us ambling up in an unhuman way, turning. All right, and then pretend you're in a drone zooming up. So we created curtain wall, took our time and got one of them correct. And we're able to gain a lot of ground by using a group function inside of that and be able to group stack that. You can see that we've got a reveal that's chamfered in on, where there's solid wall there. That's a true detail at those exact elevations. And this is just a fly around. So this is the whole deal. This is the south side. It's got atrium spaces that have been infilled as mechanical. We've caught all of the stairs, all of the kind of ribbon cut stairs that are happening there. We've got raised platforms on the roof. We got a huge mechanical piece there on the east side. That's that ADA ramp underneath that awning. And then we come around to the front of the building on the north side. You got 2 security buildings down low here. All of the flooring here is not flat. It's actually multi-slope floor at the correct elevations, ADA ramp. If you look up, that's what 20 stories looks like when you peer upwards, and it is daunting.
Yeah. Is Jeff still on the line? Because he told a story about when he first approached that building and saw that exact view.
Yeah. Yeah, Jeff had a game plan for how he and 4 other people were going to scan this thing. And when he walked up and looked up just at that spot, he was like, oh no, we're not getting this done.
Yeah.
Of course he did, though.
He mentioned he did his homework. He saw, visited Google Street View, took whatever drawings were available, which weren't actually construction drawings. They were more cartoony, and did his homework. But he said you just couldn't really understand the actual magnitude until you stand right in front of it, that last view from James's video.
Yeah.
And just look up the big old building.
That fly around would be like if you were in a 747 flying around this thing. I mean, it's a big city block.
Okay, so I think we did really well on time here. It's 3:55. So in review, we talked about linking the point cloud into Revit. We talked about confirming correct point cloud locations, both vertically and horizontally. We talked about ensuring point cloud is level. Utilizing reference planes and applying custom view properties for clear interpretation of point clouds. So we appreciate the questions that have come in that really spurs this conversation on, makes it productive for both us and everyone involved. We do have a few more minutes. Are there any more questions about best practices or anything we've discovered? James and I don't know everything, but we've certainly learned a lot on the way. If anyone else has anything to share with us, that would be great.
Hey, while they're thinking up some questions, Matt, do you mind if I share screen for just a minute?
Yeah. You can just hit share screen, right?
Yeah. Give me just a second here. All right. Can you see my Revit?
Yes.
Okay. Actually, let me hide that guy. I was just going to kind of show just a couple more things on the outside of the building and see if there are any more questions that come in. So all of these horizontal elements, the paving that you're looking at here, I mentioned that most of that is flooring. I may have some point clouds turned on here. Oh, I can see your interior model. That's what's going on. Let me turn the interiors off. Just a second. Unlink the interior model. Oh yeah, that's better. You guys modeled too much on the inside there. But this piece right here was just created as a floor. Actually, let me pick on a different one. I'm going to pick on the serpentine piece over here. So we've got a paving here that has a serpentine maneuver to it, and it's ascending while it goes upwards towards the building. We've also got those railings here. I just moved that, didn't I? I sure did. Let me undo that. Sorry, my palm pressed on the laptop while I was clicking on it. But just if you were going to measure this piece, it would be extremely difficult to pull that off in field, even given 2 hours. In all total, we set up 4 scans in this courtyard. So it went left, center, right, and then back here. And those were 3-minute scans. So inside of 20 minutes, even with setup, we were done. And it had shined all the way up 20 stories. It fired inside of windows that would later corroborate some of those interior scans that were linked to it. And so the way that this floor is put in right here is you just model it from above in a first floor plan. Let me see if I've got it handy here. I don't know what my view range is set to. Right, so you just go to architecture floor, model that in by carefully, following the exterior of it. And then later you can select the floor, and a lot of you guys that are advanced Revit users kind of know this trick, but you can select the floor and choose modify sub-elements, and you can grab an individual point and elevate it to precisely up or down where it needs to go. And that's not very helpful to do that in plan, but you would actually, the way I did it was I cut a thin section through here, looking at about just a 2-foot strip of it, and it allowed me to, in section, grab a point and maneuver it with a nudge command, just arrow up and down, and get these to exactly the height that they needed to be. So if I just, cut a section through this real quick, we should see this thing elevated as it should. Hopefully my depth won't be too great here. Revit's like, I need a minute. Give me a second here. Now you changed the depth over here. Let me look for that. Yeah, far clip offset. So let me change this down to just 4 feet. Oh yeah. All right. So then if I open up this section, I should be able to see those points that I grabbed and manipulated. Yeah. And so here I've got a floor, and I can coordinate this if I window tile it. Ooh, or I can just confuse myself. Let me close that real quick. I like to coordinate this plan view, section view, so that I can see, how to properly elevate each point. Normally it's faster than that. There we go. So you select your floor. Watch that be the awning. Yeah, that's the awning. Sorry. Select your floor down here. Boop. Choose modify sub-elements. And if you zoom in, of course, I'm covering it up now with modeled element, but you can grab your corner points of this. And you can see which one highlights. In this case, it's down in this corner. And you can simply arrow up or down was my strategy for making adjustment to this. Now, most people don't want to see triangulation occurring in a plan view. And so that's actually a setting that you can turn off. While I'm modeling it, I do like to see it because it is true to what's happening. But if you don't want to see that, you just go to Visibility Graphics, VG, and underneath Floors, just expand it. And I don't know if it's interior or if it's hidden, but I just uncheck both of those. And that will turn off that interior triangulation. Keep that in mind if you're doing, low slope roofs, etc. And if you need to turn off your point cloud, you got the ability to shut it off at least temporarily as well. Oh no, no other questions came in. See, I was just doing my song and dance so that other questions could have time to come in.
All right. Well, thanks, James. I'll go ahead and take it back from you.
Sure.
And back to the last call. I have a question about the group family thing.
Okay. I think maybe he wants me to demonstrate that quickly if I can.
Oh, okay. Well, yeah, go ahead and take it back then, James.
Will do, will do. Ooh. All right. So one place that we did that were these Merlons up here. And actually, we didn't even know that the building had these until we were able to examine the scans closer. Because if you looked at Google Street View, that kind of detail is not going to show up on it. But we just took a short crop section and created the extrusion for that. Let me see if I can emulate that fairly painlessly here. I'm going to find just some kind of a detail. I've already done the railings. This is painful. I've actually done most of it, but let me create a section real fast here. Reference plane first. I should have done a 2x video on this. And whenever I created these, I actually did have reference planes on them. Now I'm just guesstimating it here. All right, so I'll just make a section, snap to the ends. I'll scoot this dude to the side a little bit, flip it around. And this should give us a pretty short version of this. I'm actually gonna erase. You know what? Yeah, I'll just hide it. Let me be safe here. I'm gonna open up my section view. It'll have the modeled element and it will have the scan. All right, so not a lot of density going on here. At least it hasn't loaded in yet. You know what? I'll just do a piece of this. We'll just do a post, okay? Just to keep everybody engaged here. So to do model in place, you go to architecture, component, model in place. I'm going to call this a railing. Doesn't matter what you name it, but I like to try to impose some kind of a naming convention to it. And now we have all of our editing tools right here. And I'll just create an extrusion for the posts. Don't know my depth yet. I guess it doesn't really matter. Okay, and open up the section there. Hit the check mark. It creates a post that may need some realignment. I'll make one other element, group those, and show you how you can kick those out as RFA files. I'll just do one more post here. And I've got my point cloud turned off, but normally I would be reading what the actual depth of that piece is there. Bring this dude down a bit. Well, actually it goes up to here. All right, so now we've got two elements. Now I am actually in the edit mode for this NE railing one. You need to select all of the extrusions and sweeps, all the components of that with just a left or right window to select them all. Then we group them. This is the sort of secret to it. And then we'll name what's going to be the name of our RFA. NE railing one, we hit OK. And it will just group that together, which is useless here inside of Revit, except it lets us go to File, Save As, Library, Group. And now it finds that group. If you've made several other ones, you can select them there. I always leave it same as the group name, so I don't have to type it in another place. I'll just type in on the desktop here. And boom, it has pushed out an RFA file called NE railing one, I think is what I named it. I like to go ahead and ungroup that model in place piece that I did. I hit the check mark, and then we'll just double check and make sure it's there. So we'll go to open the family, it should be on the desktop. One makes so many families. There it is, NE railing one. Open it now in the family editor, and boom, there's those two extrusions that I made to their actual elevation, distance, diameter, all that stuff is correct. And so I only push it out whenever I've completed the model in place. And then I will probably do a save, and then I'll do a load into project. And if it already has something named that, then it will go ahead and create it. Don't insert it in your 3D view. Do it in the plan view that you're working in. So all of the exterior site elements, I just stayed on level 1. And that way it inserted back at the exact correct height. And I could just, scoot it to the left or to the right and place it exactly where it belongs. So that's, hope I didn't take too much time demonstrating that.
Okay, looks like he says, gotcha.
Awesome.
Right. Any other questions? We call James the Revit whisperer around here.
I received that, Matt. I received that.
Okay, from here, I believe we can wrap up. Okay, I don't see any more questions coming in. Thank you everyone for your time. I hope this was valuable for you guys.
Yeah, we want to talk about our next Universal Users Group too. So it's going to be at the start of 2020. We don't have our topic lined out just yet. We've got a little bit of runway between us and the holidays here though. But we do want to hear from you guys. And so if you could email, there it is, marketing@atgusa.com. If you have a topic idea, then you may be able to choose what we talk about next. Otherwise, if someone internally has something that they want to put forward, we may go with that. But we will be sending you guys out an invitation to our next one here, probably early January 2020.
Okay, thank you everyone. From here, we're going to conclude the meeting and I'm going to end it. Thank you.